Hello friends, so today we are going to start with this new chapter which is calorimetry, and these two terms which is heat and temperature. We have been hearing and talking about these two terms since our very junior classes, right? So right now we are going to talk about in detail what exactly is heat and temperature. Okay, what do you think so? What is temperature? See, we are familiar with the point that temperature is the degree of hotness or coldness of a body. But what if a body is at higher temperature? That means it possesses more amount of heat. So basically temperature is a basic determination of heat, but what exactly heat is doing to the body? For example, this substance, if I am heating it up from the gas below, what is going to happen to this substance? Its temperature will increase obviously, but what exactly molecular changes will this thing undergo? Okay, consider this thing, consider a glass of water, okay, and now we are placed it above a burner. So gradually, due to the heat absorbed by the burner, the water is going to evaporate. So what has happened? All the molecular motion of the water molecules that was gained by the process of heat transfer, and now the water molecules which were in constant bonds with each other, that is why the whole thing was in liquid state, they don't need any more further formation of bonds, so they got free, and the process which we saw was evaporation. So what is happening here? There is this water molecule and water molecule, they have this energy bond between them because this lacks some energy, this lacks some energy. So they both complete their energy level by making a bond. Same heat you are providing it from the below. So this and this, they both don't want to be in any further association. So they got free and they are moving anywhere. So that is what evaporation is. Basically, this is a game of energy. So heat is a form of energy, we know. This is temperature is degree of hotness or coldness, we know, but how are they interrelated? So to know that, you have to understand what heat does to a body. Heat increases the internal kinetic energy of all the atoms and molecules of the body. So heat increases the kinetic energy of all molecules or atoms of a body. So this kinetic energy, since heat is a form of energy, so even at room temperature, this marker which is made up of billion of molecules, these molecules are still at thermal agitation energy. In simpler way, they are constantly vibrating about their mean position. Why they are vibrating? Because of the room temperature, they have got enough heat associated with them so that they can vibrate to and fro about their mean position. So if you increase the heat, if you provide heat by some source, that is going to increase their kinetic energy, right? So kinetic energy associated with these molecules can be in three formats. It can be vibrational, it can be translational, and it can be exactly rotational. Okay, so these three types of motions are associated with any molecules of a body, and when you provide them heat, you provided the whole body heat, the kinetic energy, that is all these type of motion increases. So the definition of heat will come out to be in terms of kinetic energy, that is heat is average kinetic energy associated with all the atoms and molecules of a body, because heat is directly giving them the energy. See, we are actually seeing a transformation of energy from one form to another. Heat energy into mechanical. Mechanical, or this is mechanical, or what? Total energy. See, mechanical energy is sometimes referred as kinetic plus potential energy. Here, you can say that heat energy is getting transferred into kinetic energy. Yes, absolutely true. But we won't say kinetic energy, we will say total energy. So one form of energy is getting converted into another form, and these are the subdivisions. So now you have a brief idea about the difference between heat and temperature. Let's summarize them up. Here I'll be writing points for heat, and here I'll be writing points for temperature. Okay, so heat is a form of energy, we know, but the point would be it is average kinetic energy. Write down the complete sentence. Heat is the average kinetic energy of all the atoms and molecules of a body. This is average kinetic energy. Whereas temperature, this is the degree of hotness or coldness of a body. So temperature will be written as this determines, and this determines the direction of flow of heat. So temperature is going to be the deciding factor in which direction the heat is going to flow. For example, a body at higher temperature, a body at colder temperature or lower temperature, you get them in contact, the heat will flow from a region of higher temperature to region of lower temperature. So because the lower temperature molecules are in absence of some energy, they are in want of some energy, whereas the body which is at higher temperature, they already have excess of energy, so energy will flow from lower to the point where it is being demanded. Second, the SI unit of heat would be joules, whereas the SI unit of temperature is Kelvin. It is determined by calorimetry. If you want to calculate what is the amount of heat liberated or absorbed, we can do it by calorimetry, whereas temperature is measured by thermometers. This is a device to measure temperature, thermometers. And also we also have specific scales of thermometer. For example, you might have heard about temperature Celsius scale, Fahrenheit scale and Kelvin scale. So yeah, we have different sets of temperature, and I'll tell you how to convert one scale of temperature into another. For now, the measurement part was for calorimetry and thermometer. Lastly, heat is additive. Additive means a container gets 10 joules of energy from heat and 10 joules of energy from current, so total it is getting 20 joules of energy. At the end, total 20 joule of energy is going to do whatever it has to do with the container. But here, temperature is not additive at all. So, fourth point is, it is not additive. So, this is the basic difference between heat and temperature.